Miss, why do we have to write the...
All right, lesson 1.3, we're going to write expressions. Remember the word expression? What was the key thing I told you about expressions versus equations? What's the difference? Do you remember? An expression doesn't have what?
An expression. I forgot.
It doesn't have the equal sign.
Oh.
It's just the first part of the equation. So an expression is just a beginning or a portion of what would be an equation.
Oh, yeah.
It's all coming back. All right, so you should have written this in your journals. It is giving you a bunch of the key words right here for recognizing the types of math when you read a word problem. Sum, plus, total, more than, or increase by all work for addition. Subtraction is difference, less than, minus, or decreased by. Multiplication, you hear times, product, that's usually the answer of a multiplication, multiplied by, and the word of when you see the phrase, how much is 50% of 100? When you see that of, that means multiplication. And then division, quotient, which is the answer to a division problem, divided by or divided into. So these are all the phrases you need to recognize when you're writing verbal phrases or reading verbal phrases. So let's practice this. The sum of 2 and a number x. You can see the sum means what? Addition. So they put 2 plus x. The next one, a number n plus 7. So n is just representing a variable. So they put n plus 7. The difference, remember what difference means? Is subtraction. Of a number n and 6. So when it's subtraction, you need to be very careful you put this in order. Addition is a little bit less strict on making sure which number you had first. Subtraction, you do have to make sure you put the correct number first. And you put it in order that you read it. So the difference of a number n, so n comes first, minus 6. And then you see here a number y minus 5. So that y is going to go first because it's listed first. All right? 12 times a number y. Multiplication, you put the number first and then the variable. 1/3 of a number x. Again, you see they put the number first and then the variable. And you just put it right next to each other and it means multiplication. And the last one is division, the quotient of a number k and 2. So k divided by 2. This is when it's important. That's in order. K goes on top, 2 on the bottom. All right, so let's practice this. Let's look at example 1. Whoa. Put this in your journals. Okay, so you're going to translate this into an expression. So for A, it says 4 less than the quantity six times a number n. Accidentally turn the page. Number n. Okay, so how would I put this? Try not to look at the answer. How would I write this? 4 less than the quantity 6 times the number. So there's two types of math going on here, right? We have not division, multiplication and subtraction. So it's 4 less than, so that means it's going to be minus 4 at the end of it.
So it's going to be 6n minus 4.
Right. Because the 4 less than means it's after the 6n.
Yeah.
Good. All right, for B, 3 times the sum of 7 and a number y. Okay, so we have 3 times the sum of 7 and number y. So you see that 7 is being added to what? The y, right?
Yes.
But then all of that is times 3. So this is where you're going to use your parentheses. 3 times 7 plus y. How did I know it was addition?
The sum.
Yes, because it says the sum. All right, let's do the last one. This is C. The difference of 22 and the square of a number M. Okay, so what's the first part that we know what kind of math we're doing? Subtraction, because of that word difference, right? Yeah. So we have 22 minus, and then the square of a number M, So how would I write that?
Squared, so like
Yep.
square M, yeah.
M squared, that's right. Just write M with the little squared number. Any questions on how to write an expression?
That's what they're doing right now.
Mm-hmm. I want to do one more. You can choose whether you're going to put this in your journal or not.
Okay.
The quotient. We're on guided practice number 1 if you want to write it. The quotient when the quantity All right, the quotient when the quantity 10 plus a number x is divided by 2. Okay, well, first of all, what's quotient mean?
An expression. Oh, like a variable?
It's one of the ways we do our math.
Oh, division.
Division, very good.
Oh, okay. Yeah.
So the division, the quotient when 10 plus a number x. So I'm going to say 10 plus x is divided by what?
By 2.
Mm-hmm. So I put 10 plus x, and then the quotient of that is the answer to 10 plus x divided by 2. Make sense? Whatever. All right, let's look at example 2. A piece of ribbon L feet long is cut from a ribbon 8 feet long. So the cut ribbon is L feet, and the whole ribbon is 8 feet. Write an expression for the length in feet of the remaining pieces. Okay, so we started out with how long? How long was the original ribbon?
8 feet.
8 feet. So there's the beginning of my expression. And then I cut off how much?
2 feet.
No.
No.
Read at the top. A piece of ribbon L feet long is cut from a ribbon 8 feet long.
So 8.
No.
6.
L.
L. The whole length is 8, and we cut off L amount. We don't know. So you're going to subtract L. Do I have an expression now?
Yes.
Yes.
That's it?
That's it. I mean, the example, the solution, it gave you what if it was 2, but
Oh, that's
I don't need to know if it's 2. That's why I tell you to look up here.
Uh,
Okay, that's just saying, well, what if I cut off 2 inches? How would I do that? Well, I'd do 8 minus 2, and I'd have 6 left over.
right.
Well, I just want to know what the formula looked like.
Yeah.
Okay, so a verbal model, this is your definitions, describes a real-world situation using words as label and using math symbols to relate those words. So when you have an expression, instead of it being just, like 2x plus 4, it will tell you that the x represents this, and, if it had a y, the y represents this. That's what a verbal model is. So let's look at example 3. You work with 5 other people at an ice cream stand. All the workers put their tips in a jar and share the amount in the jar equally at the end of the day. Write an expression for each person's share of the tips. So at the end of the day, there's a tip jar, right?
Yeah.
With a certain amount in it.
Yeah.
So I'm going to say the amount I don't know how I'm moving some of this stuff sometimes. The amount, and we'll just call that A at the end of the day, right? And then how do they split this up?
Equally.
Hmm?
You split it in 6 people.
How do you know it's 6 people?
Because it says number of people right there. 6 people.
Yeah, you're looking at the answer though. I want you to tell me in the
Oh.
equation.
Oh.
You work with 5 other people.
Yeah.
So how do you know you're dividing by 6?
Because you're including yourself.
All right, good. Because you're also including yourself. You get tips as well. So this is the verbal model. And then you just write an expression out of that. So you would have A divided by 6. And you could also write it like this. A divided by 6.
Wow. Interesting.
Yeah. So this is the verbal model. And then this is the expression. Good. All right. A rate was another one of your words. Is a fraction that compares 2 quantities measured in different units. A great example is like miles per hour. That's a rate, right? You're going this many miles per hour. Another one is gallons per mile. I use this many gallons per mile when I drive my car. Those kind of things. A unit rate is when you have simplified it to be over 1. Okay, so if I had like, let's say I'm going 120 miles every 2 hours. This is a rate, right? A unit rate is when I simplify that to be over 1. So how do I simplify the 2 to be a 1? I just divide by 2, right?
Yeah.
Whatever I do to the bottom, I do to the top. So what's 120 divided by 2?
60.
Yeah. So this was a rate. This is a unit rate, meaning I've simplified it to be over 1. And this is more than just under miles per hour. It's any time you're dealing with a rate.
Wow.
Welcome to high school. All right, so let's do example 4. Oh, speaking of it. Nope, that was just the me telling you what a rate was.
Oh.
But it's good. I'm glad you put it in your journal. Example 4. Yeah, don't erase it. Leave it there. Oh, you're just taking off the example. A car travels 120 miles in 2 hours.
Oh, so we did use
Oh, we did do it. I just gave it as an example. Oh, but we just made it into a unit rate, but it wants it in feet per second.
Oh.
So we do have to convert it. Well, we did the first part of it.
Okay.
Sort of. Not even. Okay, so we got to convert this multiple times, right?
Yes.
Because you can see here we need miles to become feet and hours to become seconds. So we're going to do a double conversion. So we already know we have 120 over 2 hours. And remember, we're going to multiply that, and we want mile on the bottom to get rid of it and feet on the top. And then we need to do it again where we put hours on top and seconds on the bottom. Do you guys remember that? Because remember, the miles have to cancel, and then the hours have to cancel. So that way I'm just left with feet per second. See how I put them opposite of each other? Yes, it's all coming back.
Yeah.
All right, so how many feet are in 1 mile?
Good question.
I'll just tell you for now. 5,280 feet in 1 mile. How many seconds are in an hour?
How many seconds are in our 60?
That's how many are in a minute.
Wait.
Seconds in an hour.
Oh.
There are 60 seconds in a minute. How many minutes in an hour? 60. So you do 60 times 60, which is
360.
3,000.
Yeah, that's what I said. 3,000.
That was exactly what you said.
3,600.
Yeah, 3,600. All right, so now we just multiply straight across. So I'm going to do 120, somebody grab your calculator, times 5280 times 1,
No, where am I calculating?
and then divide it.
You lost it.
Did you say 120? Okay.
120 times 5280,
Okay.
which is what?
600. No. 633, 600.
Sounds right. And then I have 2 times 3600.
What?
Where's your calculator?
Oh, it's somewhere.
So what's 3600 times 2?
What? Okay.
It would be 60. No. What?
Right? 7200.
Yes. 77.
So then divide 600 by 7200.
It equals 100. 80.
And you should get 88.
Yeah, you confused me with all these hundreds you were saying. Okay.
Well, it's just these amounts right here. See, I was doing 120 by 5280, and then I did 2 times 3600. So at the end, you should get 88 feet per second. Is that a unit rate? It's a rate. Is it a unit rate?
No, it's not.
Are you
Yes,
yes, it is.
It is.
Because it's over 1.
It's over 1.
So we have the unit rate. Good job. No, I'm not going to do example 5. It's the same thing what we just did, just in words.
Oh.
All right, I believe you guys have an IXL today. So check your Google Classroom.